Okay, hello students. Today we're going to solve some of the problems from the chapter 2 vectors. Now let's look at the problem number 15. So we have a vector has an x component of 25 units, minus 25 units, and y component of plus 40 units. Find magnitude and the direction of this vector. Now, in order to understand, we have to draw a coordinate system and to draw the vector. Now, just one moment. Okay, let's draw the coordinate system. This is our x, this is our y. Now, our x component is minus 25 units, right? So let's say that this is minus 25 units, which is, let's say it's equal to the rx component, okay? Then our y component of 40 units, so it's plus 40 units. Let's say this is a ry component, which is equal plus 40 units, okay? Then we can draw our vector, which means start from 0 and up to here. So this vector, we call it r, okay? Now, obviously, you can find the magnitude of the r vector using the Pythagorean theorem, which means r is equal rx squared plus ry squared and under the square root. So let's plug the numbers. So r is equal, our x component is minus 25, which is squared, plus 40 squared. So if you do calculations, you should find that your r vector should be equal to 47.2 units. Okay, now how can you find then the angle? The angle, which is this one, let's call this reference angle, okay, theta r. So obviously this theta r can be found by inverse tangent r y divided by rx, okay. Then let's plug the numbers, which is tangent inverse tangent ry is equal in our case 40 units divided by minus 25. Here we can just take the model of this one because we are looking for only the positive number, minus 25 in the model. And if you do calculation, your reference angle, which is theta r, has to be equal to 58 degrees. Now, we found that theta r is 58 degree, but we are looking for the angle from the positive x until here, okay? So this one, let's call it just theta. So our theta is basically will be equal to 180 degrees minus reference angle, which means 180 minus 58 degrees, which should give you 122 degrees. This is how you solve the problem number 15.